And welcome to another webinar webcast of RavenDB. And in this case, I'm with Justin, and we're going to do some pairing on a sample application that he wrote for RavenDB, which is RavenOverflow. Justin, do you want to talk a bit about this application?
Sure. Hi, everyone. So I've been trying to learn some RavenDB, some pretty basic concepts. So I came up with a quick app called RavenOverflow, which was an exact rip of StackOverflow. It does looks similar. I just viewed the source and grabbed the HTML and put it into an ASP.NET MVC3 app. So it's not very complex, and I just did the front page, the home page. So it looks very similar, and of course the storage is using RavenDB, not Link to SQL or EF, which I think those guys are using. So that's what the app is. It's on GitHub, so anyone can have a look at it.
So let me just give you the link. This is on github.com/Justin. What is
Pure Chrome? P-U-R-E-K-R-O-M-E.
So here is the actual application. You can go and download the code. Presumably by the time you actually listen to this, we will have the changes from this webinar available in here. And I obviously already downloaded that, so let's just start from scratch, and this is how the application looks like. This is when it has no data. Okay, so obviously this is fairly uninteresting thing to see. So let's go, and as part of creating this application in the startup, we're going to create some dummy data. So we have to rebuild, and as you can see now, this is now showing some data to the users. It's not very interesting data. It's basically all generated using AutoBuilder. Is that it?
It's called NBuilder.
NBuilder.
Something that's on NuGet.
Okay, so basically just some stuff here. Let's look at the actual data model that is behind everything. And so this is a question. It's a fairly uninteresting one, unless you speak Pig Latin, I assume. And you can see that we have some tags, we have some votes for that, and that's about it. Interesting to note that, again, if we were using a relational database, this would sit in 3 different tables at least. Because we're using RavenDB, we can put all of these complex objects into a single document. In addition to questions, we also have the notion of users. So let's look at the users, and we have users which have very strange favorite tags. This is what happens when you use random a lot. And okay, so we have this Jacqueline Diaz, who has a favorite tag of elite, which is, amusingly enough, this is a company in Israel. Okay, so let's see what question do we have now. So what does the question is doing? So list all the questions with the order by created on descending. And I think that you already have this done. Let's take a look at the home controller. And you know what, let's just make things slightly easier. And by the way, if you want to know about how to manage sessions in RavenDB, it's actually the actual case is that there is almost one-to-one mapping between how we manage a session using Hibernate, how we manage a session using RavenDB. That is because they were intentionally designed to be very similar. So I'm going to skip using the question service, mostly because for the purpose of this webinar, it's going to actually distract us. So I'm actually going to remove it. And now we have like this document session query, order by descending. So this is basically using a link, give me the latest, 20 questions. The second problem is actually more interesting. Give me all the tags, but ordered by the most recent tags. Now, if we go and look at the actual data, let's look at some questions. You see that we have a tag, ASP.NET MVC3. Another tag that we have is another MVC ASP3. Let's see another one. RubyChem, RavenDB. But what is the what is the meaning? We don't have something called tags. What is the meaning of most recent tags?
Yeah, we don't have like a class object. It's just a list to represent what the question's about.
Mm-hmm.
So it's some keywords.
Okay, so what is, when you define the most recent tag, what does this mean?
For most recent, what I was thinking of doing was finding out the questions in, let's say, for the last 30 days, and grouping all the tags by that question, and then the highest count is first. So if there was 100 questions in the last 30 days, and out of those 100 questions, 50 of them said RavenDB, that seems to be the most popular. And that'll be the first result.
Okay. So what you're basically asking is, given a specific range of values, find some specific things in that, right?
Yes.
Okay. So given a date range, find counts within that range. This is actually fairly interesting problem. Interesting means complicated. When I'm looking at a list of all recent tags, I would have defined it more simply as a tag is as recent as its most recent question. Okay?
Okay.
So let me try to solve that problem first, and then we will deal with the other one. So the first things that we need to do is to define an index, a RavenDB index, and recent tags. Abstract index creation task for question. So I'm going to start with the following index. Sorry. So this just gives me all of the tags across all of the questions. I also need to get question dot created on. Nothing like that. So now that we have this, we can also. So what this gives me is a tag, is a list of tag and the value of the created on value of the question. So the next thing I can do is this. We need to define the reduced result.
Is this new, how in Raven that you have to have a strongly typed reduced result?
If you want to use the strongly typed version, yes. This is also a convention that we have started to come up with for using MapReduce indexes. So now we're doing like this. And this totally freaks me out. The fact that you can do something like that. Okay, because you're basically using the this is just crazy. Anyway. So now we have this, and now we can do reduce group result by result.tag. into G. Okay. So let's look at what we're actually doing here. The output of this index, this is a MapReduce index, so it's composed of two stages. The first stage is going over all of the questions and outputting the tag and the last seen value. So, which is when the question was created. The next.
So if you didn't have the reduce then, and this is back in, like, if this is a SQL query, that'll be listing all the tags and the date that it was used on the question.
Yes. Yes.
So if I had two questions, question one had tag RavenDB on the first of the month,
Let's just
and the
do
second
this.
question.
Let's just do this. We will ask it to store. Yes, and we ask it to store. Yes. And so now we've just created a simple map index.
Yeah.
And we are going to go to the global and just avoid this one. So we don't want to create the instance every single time. What we do want to create is index create indexes, type of recent tags, and we have discussed one. So what this does is basically make sure that RavenDB has this index.
Mm-hmm.
So now I'm going to get an error because we are missing a reference.
Yeah. Yeah. Index creation.
Yeah. So
And that scans all the indexes, so when you get more, that they'll be added into.
exactly. So now we can see that we have this index defined in here.
Cool. Now, if that index is already defined, and when you start your app, does it re-index, or it ignores it because it already exists?
If it is the same, this is a no.
Great.
So I'm going to go to indexes/recent tags, and this actually, the default output of an index is actually the document that we indexed. But we can also ask it to fetch the actual values from the index. In which case it's going to look like this. You see that here is a good case. You have question number 2 that has tags ASP.NET MVC3 and YI compressor. So this is 2 tags and it was outputted from this case. And you see that this is the default format for dates. You see 2011, September 10th, and blah, blah, blah. Doesn't really matter that much.
Yep.
But, so this is the map output. This is what this thing generates. Now, we're going to basically say, okay, I want you to make, so when we use the reduce, we're actually going to say something like this. Okay, I want you to do a group by the tag. So let's look at YI compressor. Let's see if we have another one of them like those.
Oh, look at the first 2 above you.
Okay, here's a good one. Okay,
Yep, question 1 and 2.
So we're going to group on them, and then because we're using max, we're going to actually output only the last one of them.
Yep.
Let's see how this looks now. We've created this. And now, for recent tags, because this is now a MapReduce operation, okay, this is interesting. I think I know what the problem is. Okay, you see this problem? We get an error when indexing. And the reason is fairly stupid. We have to do it like this. And this is insanely stupid. This is a bug in how we are generating stuff for because daytimes on the server side, never mind, this is a bug that we need to fix.
Cool.
And good. So now we can go back here, and now you can see that we have this value here, right?
Yep.
That doesn't tell me anything. That just tell me. So this
most recent time.
Yeah, the most recent time that this was seen. I can actually do something more interesting and say, okay, count equal g dot something like this. If I will try to execute this, it will fail. It will fail with a very interesting error.
Do you have to update the reduce result?
Yes, exactly. So you can see it here, the result type is not consistent across the map and the reduce. So in the reduce we have a field that isn't in the count, and that is not a valid. That is not valid because of the way that we are doing map reduce. We are doing that incrementally. Is that how we said it? Incrementally?
Yeah.
Whatever.
Incrementally.
Yes. So we're doing that in small increments, and we have to make sure that the value is the same across everything, because we may actually use them in the same fashion. So count get set, and we can't use count. We have to use sum. So this is required to allow us to build the index in small increments instead of doing all of the work all at once. So it is now created, and now it actually works. And now we go here, and you can see that now you also have the count of value in that manner. Now, why is this important? Because now that we have defined this fairly simple index, we can now remove this because this is the default for MapReduce. Now we have defined this very small index, we can actually ask it some interesting questions. So if you want to ask, show me the most popular tags in the last 30 days. So popular tags this month, and so query of recent tags reduce result, recent tags, well, order by so this is how this is done. Okay?
Yep. So the difference between this and the first one is now we're hinting with the index to use.
Yes.
While the first one's a dynamic query.
Yes. So the first one, we are letting the index optimizer do its work. If there isn't an index for that, it will create one. We can actually probably go to the UI and look at the. Here you go. This is the index that we created. That was. That we didn't create it actually, that the index optimizer created for us. So now that
suggested attempt there.
Yeah. And now we have this one, and we have old errors that we already fixed. Okay, so the next stage is to actually let's answer this question: list of all the favorite tags for the logged in user. Well. How do identify the logged in user. Let's say that the logged in user is identified by request string user. Let's make this and document session dot query user.
Yep.
What's the default? Okay, and now use of favorite tags, and this may be null if we don't have a logged in user, so we'll actually just do it like this. If user, just put in some defaults, that's it.
Yeah.
Okay. Authentication view model, what is that?
Don't worry about that. Don't worry about that.
Okay. So now we have, you know what, let's make this easier. JSON. So the only thing that I'm doing, I'm just outputting JSON because that will allow us to more easily see what we're actually sending to the user. So in this case, you can see that we have questions. We have the popular tags this month, and we didn't specify the username. So let's go in front of the user. Let's first use the with some tags. Another user with some tags. You're kidding me.
Just add some in.
Yeah, that's probably, that's the easiest way of doing that. Username. And now we can see that we got these tags here. Okay, so I had to query by the username, and we just pull it directly from the document that we got back.
Cool.
If we go to users, one second. If we go to users, you can see that we have now defined an automatic index, temporary index for searching by the username. Yes. Any question?
Cool. Now, yes. Can I throw a curveball here now?
Yes.
Cool. On Stack, their tags are actually like root aggregates. So if you open up StackOverflow, and then we'll just randomly pick a tag, you can see that they've got like a tags page. So I was wondering if
so let's go
the
for StackOverflow and let's look at my favorite tags. You're talking about something like this, right?
Yeah,
and
that's correct.
That gives us all of the questions tag with a specific tag ordered by their creation date.
Question post. Yeah.
Okay.
Now the concept here I'm thinking is, from a model perspective, is tags. I think sound like they're a root aggregate now. So does that mean that maybe?
Not really. So tags aren't actually root aggregate because the fact that I'm looking at them doesn't mean that they are aggregate. It just means that they're annoying. So let's see. I want questions. I want to order them by created on. I want them to be the last 20, and I want them to be okay. Like this. Okay? Let's look at how we actually use that. So right now I see that we have several questions with the tag RavenDB. So let's search for RavenDB. Home/tag/ this should give us, okay. So here is a question that is tagged with RavenDB. Here is another question tagged with RavenDB. Okay? So we don't need to create a root aggregate. We can just go directly into the guts of the question and pull that value back.
Yep. What happens if the tag has extra metadata associated to it?
Oh, so let's say, so give me a type of metadata that we care for tags.
Yep. Go back to the stack page, please. Raven is an open source document database. Yep, that's it.
At that point, I would actually go and create a tag document, yes.
Cool. So that's what I was wondering. Yep.
Yeah. But notice that at that point, we'd have something like this. Document. Okay, and now I've created that, I can do.
So is name your like the primary key for that document?
No, the primary key for this document is this.
Sorry, yes.
Okay.
So where did you get RavenDB? Oh, did you type RavenDB in at the top for the key?
Yeah, I literally just typed that. Yeah.
Manually type it. Yep, sorry, I missed that bit. Cool.
Okay, so document session dot load. We don't even.
So do you do that a lot where you have a property on a document? In this case, it's called name, and the document key is basically the same as the name.
I usually just skip that. No, I usually skip that. Something like that is pretty much meaningless because I can already figure that from here.
Correct,
So,
and you have maybe like an accessor that just strips out the tags / and then you've got the the name of it. Okay, cool.
So something like that, and I'm going to execute this query again, and you should be able to see that. Okay, we got this question, and we got the description for that. Oh, use dynamic. So 1 second. Tag. Question. Okay, and now we come back here, and now we have the appropriate description for that.
Sweet.
Okay, now notice that the tag is represented in several fashions in here. You have the tag document that describes the tag. You have reference for tags, such in this case. You also have this one, the recent tags, which contain the stats for this tag. You see?
Sure do.
So let's see, right here we wanted to show also the number of question tags with this. There are several ways of doing that, and here is what is probably the simplest one. We are already making a search on questions that are tagged by this ID. So we can also ask RavenDB. I hate that it does that. Using raven.client. This is a bug in ReSharper that keeps screwing up stuff for me. And now we have stats. Okay, so now we can also report not only on number of questions, not only on the last. So this will contain the last, I think, 20 questions, and this will tell you how many questions are there for overall.
Okay.
So we have just been able to get a lot of information about the tag in a very efficient manner.
Can you go back to the code again, please?
Yes. So what we have done, we basically asked it, give me the statistics for this query. And the statistics for this query allows me to get a whole lot of data about this item, about this query. So I can look and see what is the index that was used if we let the query optimizer handle that. I could look when was this index used, whatever it was stale or not, all sorts of stuff like that.
So that's a good place where we use paging then, using this stuff out.
Yes, exactly. And now let's look at this problem. Okay, so what is the difference between these two statements?
Okay.
The second statement is checking a tag. So let's say that you have that you want to look not on the actual overall popularity, but over popularity in a specific date range. So let's say that you have you had the technology that was very popular at a certain age, let's say ASP.NET Web Forms, and that is now become less and less popular. So at some point it had 10,000, so it has overall 10,000 questions in the database, and it is the most popular topic overall, but you care about a trend in popularity. So in the last month there was only 2 questions about it, so it shouldn't be ranked very high, right?
Correct.
Okay. So that is the major difference, and that makes it a lot more interesting when you consider how you do that with RavenDB. This is mostly because of the way RavenDB works. We don't do any computation during the queries. That means that how do you make something like in a specific date range and then get counts over that? So the answer to that is to actually use facets. And let me show you how we can use facets. In order to use facets, we need to define them. So I'm going to go here. Define a session. And session.store. Okay. Facets. Sorry. Facet setup. And the ID is raven/facets/tags by range. What is a facet? A facet is basically allowing me to ask what are the values, what are the unique values in a given range. So the new facets that I am going to have is, we'll explain how it works in a second. Name is tag. So I define a new facet, and I'm asking it to give me the facet over tag. This basically asks me, give me the, okay, I cannot explain it without doing a sample. So one second. So again, document session.query for recent tag with this result, recent tags. And what do I want to do now? I want to do actually the scene is greater than datetime.now. If I would do that, that would give me all of the recent documents. I can also do this. And Raven/Facets. And let's see what this gives me. Okay. So on startup, it will create this document, and then we will make this query and ask for facets for that. So let's see.
Okay.
/facet. So this is an interesting result. What this basically says is that in this result set we can only find. Oh yeah, of course. I'm sorry. We make a query over recent tags. Of course, it will do that. A question. We checked the wrong result. And we want that. And no, we need to define a new index. Recent tags. Recent tag map only. So we need to actually So why do we need to do that? Because we actually need to have an output that isn't aggregated on. If you remember the first time that we've done this, we had the tag and that, so we need to run the facets on that output. So we define the map only. And we go here and we say that we're doing that on this and like this. Now we're going to try and okay. So now you're getting something very, very interesting. Look at this. This is the count of items that are in the current range that match this value. And let me just show you what I mean. Let's look for a document. And you can see that this is the value of Ruby Games. Ruby Games has now 12 items. I'm going to change the date of the question to 2010. Save that. And this should now switch to be 11. And it has indeed switched that. Perfect. So, what is actually going on in here? What the hell is this facet thing? Let's just look at both of them together. So, what we have actually defined is can actually do it like this. This would make more sense. So what we've actually defined is something quite interesting. We've defined the ability to ask, give me all of the count of all of the unique item participated in this index. That matches this query. That makes absolute no sense when you start thinking about it that way. Let's look at what the results are, and then we can follow what's going on in here. Okay, fetch equal tag and fetch equal last thing. Yeah, so actually need to again mark it as store.
So what exactly does that do when you say mark it as store?
It allows me to look at the values that are stored in the index. It means that it takes slightly more memory, not memory, slightly more disk space to actually look at the values, to actually store the values, because it has to preserve them in the index as well, but it means that I can actually look at them like this. Otherwise, it just keeps enough information to be able to search on that, and not enough information to actually look them up again when I need them. So this is how the index actually looks. And you can see that somewhere around here, so I have nothing here that is before before last month. So that RubyGem question that have moved to 2010 will not show up in this in those results. Now, what Facets do is basically says, okay, go and find me all of the values of tag, all of the value of tag that you can see, and give me the count of the results in this query.
Mm-hmm.
So, and that is what we're basically getting when we're doing, okay, when we're doing this.
Yeah.
Okay, so, I have ASP.data MVC. How many times does this appear in this query?
Yep.
Okay, so that basically gives you what you want. And using that approach, you can do this sort of dynamic querying, the dynamic aggregation very, very efficiently. The way that this is implemented in RavenDB is extremely efficient, as long as the number of items that you have here is relatively low. If you have, 10,000 items that are matched in this query, you might have a problem. But as long as it's in the several dozens to few hundreds top, it's perfectly a reasonable way of doing that. Another thing that we can do, we can also say, you know what? Let's modify the tags document. Actions. What? I'm pretty sure I tag. Okay. So another thing that we can do is something like this. So what we are going to do now is to say, okay, I want to see the count. Now what I want to do is even stranger than this. What I want to see is not just the count of this, I want to see how many of those tags had count within specific range. So in this case, if I don't remember what the value is in a second. So in this case, we're talking about 0 to 100, let's say 0 to 10, 10 to 20, and
Typo, yeah.
good enough.
Is it case sensitive, the TO?
Yeah, it is. Now if I'm going to execute this now, and if we had a count property here, it would work on that. But you know what we can do? We can still do something. Let's tag range. Want to say from A to let's say E, from F to X, from Y to Z.
Mm-hmm.
This is very, very stupid way of doing things, but
Typo?
Well,
Y to X, Y to Z.
yeah.
Cool.
Hello.
Oh, the beauty of pair programming.
Yeah.
Cool.
And let's say is I hate when he does that. To minify. What? This is not plugin, this is tag. Let's move this one. See how this works. Okay. Something is on, I'm not sure what it is. Let's see. Oh well. Oh, here we go. So, case sensitivity issues. So A to E, we have 19 tags that between A to E. And now we have F to X and Y to Z.
This is like voodoo magic, how it does this.
Yeah, this is now look at this. This isn't really interesting, right? Why would you want to ever do that? Well, the answer is that this is actually quite common. What?
The new docs?
Probably. Let me see. No, it's not in the window. I think it's okay. Yeah, it's not. It's not linked to anything. So let's take a look at this one. Okay, this is what the facet is actually. So we have played with the stupid stuff, but look at this. A tag range would be something like from 6 megapixel to 8 megapixel. We have 3 of those. And from 8 megapixel and up, we have 14 of those, and stuff like that. This is where facet ranges are very important, because they allow you to do this sort of stuff very, very efficiently. You can also see that you can do price ranges and all those sort of things, and they basically allows you to slice and dice your queries in a very efficient manner. The fun part is that they're not just useful for that. As we've seen, it's also very useful for you to actually being able to do counts on dynamic ranges, for example, stuff like that.
Yep.
Okay.
So can you sort of say a simplistic way of how we were doing it was A to A, B to B, C to C?
Yeah.
I was just doing a count. Yeah.
Yeah, it's basically just doing a count. And the interesting aspect of that is that it's very fast to execute. Even obviously we're doing that on a very small data set, but even for large data sets, it's very fast to execute. But the important thing is that it gives the user a lot of control over what actually you have available to you, what you can actually do. It also gives you, do you know that sense that you search on Google and it magically knows what you meant? Like if you had to write this software, you would never be able to figure this one out. This allows you to do these sort of things. You know what? Let me show you something even cooler. Let's say that you're like me and let's say that you're like me and so now we have Tag Finder.
Yep.
And what this basically means is that I want to find a tag. So I have the list of most recent tags. Let's do tag stats. That's more interesting. Document session.query recent tags.reduce resolve recent tags. Well, So far it's fairly simple, right?
Yep.
And we're going to, oh, no. We're going to get pretty much what we expect from here. /home /tag stats /RavenDB. What happens if I do this? Why didn't it find anything? Do you see that? We're looking for RavenBD.
Typo. Yep.
Yeah. So, but this is very common, right?
Yep, sure is.
Let me show you how we can fix that.
Okay.
I want to use this one. So let's look at something like this.
Yep.
Now we're going and looking for this typo. Notice what's going to happen. It fixed itself. Did you see that?
I think I saw some unicorns fly out of my computer. That's so awesome.
Yeah.
That's cool.
Now let's look at Ruby.
Cool.
Okay, Ruby Gem, Ruby Gems, Ruby Gem, stuff like that.
Yep.
Now let's look at
What's something similar to get two results?
1 second. I want to see.
Maybe add another one so we can get two or more.
Yeah. So let's go and add a new Ruby Gem and Ruby Gem and Raven.
Yeah.
Just Raven.
And Raven embedded. Add one more.
Yeah.
Sweet.
That is one
Sweet.
switch question. Okay, so now I'm going to look for Ruby. Raven. It's actually quite hard to make it fair. One second. Do we save that? Yes, we did. Let's look at this. It's interesting.
Index?
It did index. Oh. Look like we have some problem here. 1 second. Okay. We're running on a development build. I'm just going to. So what I just did, I restarted the database. This development build that is extremely unstable. And let me just. This is just.
Don't forget to uncomment the seeding.
Yeah, yeah. So I'm going to actually comment this one because this is too smart. I cannot get. I literally cannot get it to fail. It's MVC application.
Yep.
So now we've done that. Now let's look at. Didn't I told it not to do that? Pretty sure I did.
Double check the tags that are in the DB now.
No, there isn't any tags. Oh hell. 1 second. I actually, because I use redirect permanent, I think that the database actually, okay, yeah, it might be different tags. Indexes. Oh, yeah, we don't have that.
That's a hard-coded list, I think.
See that?
Yep.
And just by, this is ridiculous, but just by adding this, you're making the application that much smarter by a huge degree. And if you have more than that, you can try to decide what is the more relevant one. You can just tell the user, okay, we couldn't find here are additional suggestions. It is just this stupid thing. You saw it. We wrote it like in 5 minutes or less.
Yeah.
Gives you so much power to control how you're working. And
is there any weighting on the results coming back from the
No.
suggest?
No.
Okay.
So it basically uses just the exact same way that the exact same indexes that you have already. So there's absolutely no weighting or locking involved in that.
Cool.
Yeah.
Love that. Autocomplete. Everyone can do it now. Smart autocomplete.
Yeah. Let's see if I can try again to cheat. It's let's ASP.NET MVC2. Okay. Whatever. Dev build should not be used for demos. That's the lesson from today. Anyway, so I think that this is it. Do you
One
have
last question.
questions? Yes.
Yeah, one really last question. Could you bring up the go to the home controller, and instead of returning JSON for the index action, could you return a view? And let's look at the Raven profiler for a second.
Oh yeah, sure. So we haven't even talked about Raven profiler. Yeah, it will not work because I shut down the server. 1 second. So now we're starting. Give me a second. Because we did the initialization of startup, the startup didn't run because that was wrong. Now it will work. Okay, so now I can see that we have 3 different queries.
Awesome.
Just so the people who don't know, this is the RavenDB profiler. It is meant to be used in production. You can see it on imd.com. It's running there. It is being wired from here, like this. This is intentionally, this is intended for MVC applications. You also have to do some stuff in the layout, if I remember correctly. Here it is. You have to do this, and that's it. So you wire this line, and you wire this line, and then you get this, and you get full understanding of exactly what's going on in the application. But notice that we have been doing that, and let me refresh, and notice the drop in the time sent to the server. That was the first query. It wasn't that efficient. The more that we use, the more efficient it becomes. Oh, by the way, remind me to talk about this one. You know what, let's talk about this one right now. You see that this sends a date to the server, and you can see that this is not cached. Because we are always using a different parameter value, when we use date, we have to be aware that of how we're actually doing that. So let's go to home controller. This is almost always a bad idea. Datetime now. Because every second, every millisecond actually, we have a different one. If we use this one, datetime today, that means that it would switch the value only every day, and we get very good cacheability out of this model. So let's look at this now.
Oh, okay.
You see that now we don't have any cache, but you see that the value is now stable.
All the zeros there.
Yes.
Yeah.
Now next time that we try it, everything is cached. The more that we use it, let's see, the faster it becomes.
So why was that affecting the other two?
It wasn't affecting. Those before that, those was 304 and 304, and that was 200.
Oh, sorry, I missed it. I was just looking at the third one.
Yeah.
Okay, cool.
Now we still.
Now,
yeah, go ahead.
sorry. Okay, now that those are doing 3 requests, and it says that in the very top there. Is it possible that those can be batched into one?
Yes. Lazily.
Lazily.
And what's the problem? Value. Now we have user favorite tags, and in order to do that, we also have to do lazily and also different. Like this. So now we have done it like that. Let's see how this behaves now. Now we've made only a single request to the server. And you can see that if we drill down into this, you can see that here are the individual requests that we've made. And here are the results that we got. So when we are running in, see, by the way, even more interesting, see that we get 200 for this, but look here, for each individual request we get 3 or 4. So we still, yeah,
that's important.
So we still save on going on just the bandwidth of getting the full request back. And again, so it's pretty much 4 milliseconds, and I think that's pretty good. The interesting aspect of this is that when we're sitting, this is a local database, obviously, but if you're using a remote database, this would actually significantly reduce the time of actually providing answer to the user, just because we are saving on the number of round trips.
Exactly.
Yes.
Right, and that can also do when you do multicat. If we didn't have date time today, we were using date time now. The first 2 results would be 304, and the third one would be 200.
Let's look at
so
those.
it can handle the
So it can absolutely handle a
multi-task.
yeah.
Yeah.
So you see that now alt is 200, 200, 200. This is the first time that we run the application. Now we try again. We have 304, 304, and 200.
Perfect. Sweet.
Yeah. And let me show you something else that is nice. Using document session .advanced .document store let's say that I want to be really aggressive about my caching. So by default, as you've seen here, then we will go to the server and check whatever the values are okay or not. Whatever you need to update them or not. But you can also say, you know what, I'm good with you not going to the server for that. So we can now do something like this. And we restart. This is the fourth time, and you can see that it took a while, and we went to the server several times. Next time, we never even went to the server.
Wow.
Okay?
More unicorns.
This is, yeah.
Awesome.
So this was actually aggressively cached, never went to the server, everything is good.
So traditionally, developers might end up, if that option wasn't there, I might have, let's say, for example, put the user result, the questions result, and the reduced results into the ASP.NET cache. That was maybe something people might have done, or a distributed cache or something. But now we don't have to worry about that. We just wrapped it in the aggressively cached for.
Yes.
You're doing that for us now.
Exactly.
Awesome.
And now, you have to know that this is something that you want to use only when you're actually using something that is known to be so usually don't need to do that. That's important to understand. Usually you can just avoid doing that because we'll do the automatic caching for you without you having to do anything. The three or four checks.
But that just stops it going across the over the wire.
That still goes over the wire to make a check if the value have changed or not. But you save on all of the work that the database has to do to feed the query, and you save because the actual process of checking the query yes or not is actually also very important. It allows you to decide whatever on the server side, checking whatever a query is still or not is insanely cheap. We have to check basically a couple of to make sure that a couple of queries are okay. That's all. So we don't have to perform any work whatsoever. So it's very cheap. You still have to go over the wire, which is where most of the cost is, but you also have the guarantee of no stale data. With aggressive cache, explicitly says I'm okay with having stale data for a certain period of time. And by just specifying that, you're just running with that.
Cool. Now, with that, the aggressive caching, or even just doing the lazy there, see how we've got for the user, we can pass in the username?
Yes, here.
So we weren't doing that just then when we're looking at the profile results. If we play with some usernames that come back,
let's see.
Every time we hit a new username, that'll be a 200, but the other ones will be a 304.
Yes, so you see 200, 304, 304. Let's see.
And the same thing would happen for the aggressive caching when you put that inside the using block?
I don't know. Let's see.
Okay.
It should. Let's see. So we start with ON, and now ON is not cached because we restart the application. Blah, blah, blah. And now we're using. So now we'll see. We never send the request to the server. And now we see that we did send it to the server, but we only sent this one. The other two we sent null, basically saying, don't even bother, I already have the answer.
That's awesome. Awesome
Yes.
sauce.
Yes.
Cool. Cool, cool, cool.
Okay. Any more questions?
No, that's plenty right now. Lovely.
Okay. Wonderful. Absolutely wonderful.
Thanks, A&A.
Okay. And to the people listening, I hope you enjoyed that. If you have any questions, you can ping us at RavenDB@googlegroups.com. The website is ravendb.net, and we hope you had fun.